My name is Ben McKenzie. This is Physics 2, Lab 2. Here's the link to my code, but it's also down below if you don't want to type it. The initial values, we have the length of the tape, the mass of the tape, the distance between the two tapes when they first started moving, the force of gravity on the tape, and then the force of the electric field on the tape. The main changes from Lab 1 to Lab 2 are how we go about our calculations. In Lab 1, here, we have assumed the tape as a singular point charge. In Lab 2, we have assumed a line charge, or a number of small pieces that sum up to be the length of tape. Our assumptions are the same, that tape A and B have the same charge, that the system is static once equilibrium has been reached, and that the charge for each of the small pieces of tape is distributed equally. The fundamental concepts and calculations involved are Newton's second law, gravity, superposition in order to sum the point charges of the pieces of tape as a line charge, and then Coulomb's law. Now, the difference where we have the point charge here, these are using the charge values Q from a singular point charge tape. You realize that the magnitude of the electric force is not equal to the gravitational force because the point charge value is off, because our assumption was inaccurate. Now, going to the distributed charge, since we are approaching, from one singular piece in the middle to 10 pieces, the charge is a lot closer here. Of course, if I did more pieces, we would have gotten even closer to the true value of the charge of the tape. What if? So in the previous lab, we modeled the same tapes as single point charges. And we compare the estimated value of the charge we get, and we use our experimental data to produce a point charge model, and we're comparing that to the line charge model. The point charge value of the tape was 1.4 times 10 to the negative 8th coulombs, and the line charge value was 2.9 times 10 to the negative 8th. The increase was 106%, which is quite a fair amount. We are off by a factor of 10 to the 2. The two computational values for the charge, the point charge versus the line charge, will be different. Why? They're different because the assumption for the tape being a point charge is very inaccurate and quite a stretch, whereas the differentiation of the tape into length of delta L is approaching closer to the true value. If we consider delta L being infinitely small, that is, delta L approaching dl, similar to an integral, or exactly the same, I guess, the charge would approach the true value. So, which value is more likely to be closer to the real value, and why? That is the y, and the line charge, therefore, would be closer to the real value.